So we've seen the conceptual data modeling and logical data modeling and physical data modeling. And also we have seen the necessity of creating the relationship in Power BI. Without creating the relationship between the tables, it is not possible to create a report with accurate results. Okay. If you don't have the relationship defined or created, you cannot do slicing and dicing. So what is slicing and dicing? What is slicing and dicing? Can someone tell me? Data warehouse guys can tell. So how many of you worked with cubes, multi-dimensional cube? So slicing is something like narrowing down to your specific set of data. For example, we have 4 different regions we operate. One specific region alone, I wanted to see the performance. So in that case, out of all the regions, you're narrowing down to specific region. It's something like, you're taking a specific portion of the data. So this is your entire data. Okay, you are taking only, you are slicing this data. Okay, you are interested in only in South region. Let's think that way. Okay, so you are slicing this specific data, and then here you do the dicing. Dicing is, here you do multidimensional. In the South region, what is the quarter-on-quarter sales performance? Okay, quarter-on-quarter, week-on-week sales performance, and again within the say the South region, store-wise, quarter-wise sales performance. You want to see that? Okay, so that is your dicing. Okay, within that specific portion of the data, you are doing further analysis. That is called your slicing and dicing. In order to do the slicing and dicing, you have to define the relationship in Power BI. Whereas in Tableau and other tools, you don't have to define the relationship on the Tableau and ClickSense. Okay. So if you don't create the relationship, this is how your report look like. So in the x-axis, you have a text column called a month name, right? And then y-axis sales amount. Each month, what is the total sales? But if you see this pick here, so all the month, the sales volume, the sales amount remains same. Okay, this is not possible, right? So there is something wrong with the report. The reason is, look here, you have two columns, two tables, a table and order table. These two tables, we did not create a link or the relationship between the tables. Hence, the report appears like this. This is what we have seen it in the last session. And with relationship, with the relationship defined, you can do the filtering. Otherwise, the filtering cannot happen. Okay, the filtering cannot happen. So what do you mean by filtering? This is my country dimension table. This is my sales fact table. You just think that way. So in the country dimension table, you can see that the country ID is unique. You cannot see the same country ID repeated more than once. It is unique. Okay, US appears only one time. AU appears only one time. Germany, the GE appears only one time. NZ, it appears only one time. So here, that is what your dimension table. This is your primary key. Primary key in the sense, the column. See, in this case, the country ID column is the primary key. Hence, you cannot see the duplicate. So this is your dimension table. Okay. But here, along with the ID, you can see the name of the country. Okay. And here, on the right hand side, this is a sales fact table. Here, let's say you have a reporting requirement wherein you need to display the country name along with the number of units sold and total sales. So here the quantity and sales, these two columns are available in this table, but the country is available in this table. Hence, you need to query these two tables in order to display the quantity and sales along with country name. Okay, but here you have only country ID in this table. You don't have the country name here. Hence, obviously, you need to join these two tables to display the corresponding country name along with that, the aggregated values for these two numeric column. So in this case, since we are querying more than one table to create this specific report, we have to create the relationship between these two tables. So how do I create the relationship between the two tables? Based on the common key column, the country ID and country ID. Only these two columns are common between these two tables. Can you see country name here? No, right? Can you see any other column here? Nothing, right? So the country ID and country ID, only these two columns are matching between these two tables. Hence, you need to create the relationship between these two tables based on the common column country ID. Got it? Based on the country ID column only, you can create the relationship between these two tables. Once you define a relationship between these tables, what happens is the filtering is happening automatically. So here what happens, so now we have created a relationship between these two tables based on the country ID column, right? I just put the link here. And what happens is behind the scene, the country ID US will be propagated to this table. Propagate in the sense the country ID US will be sent to this table. The moment it receives the country ID US, it goes and groups all the columns, so all the rows that have the country ID US. One second, please. Hello. Understood. The moment you create a relationship between the two tables, what happens is it passes the key value. So the key is country ID, which is nothing but US here. The US will be sent here, since this is the first record, okay? And in this table, it applies the filter on the US, US on the country ID column. Okay, all the US country will be grouped together. Okay, and here and then what it happens is it does the sum. So it does the sum on the US related quantity. So US related quantity, 10 plus 6, 16 plus 2 is 18. And then it adds all these US related sales values. Once this has been done, next it goes to the second record, AU. The Australia data will be, the key will be propagated to this next table where and all AU is there, right? That record will get grouped together and then it applies the sum on the quantity and sales. So in Australia, what is the total units sold, total sales we made? In USA, how much total units we sold, how much total sales we made? Similarly, all the other country area also, it does the same thing. This is called filtering. So relationship here in Power BI is nothing but filtering. Whenever they say filtering, that means, the relationship, okay? The cardinality or the relationship, okay? So this is what you should be knowing it, okay? So without creating the relationship, the filtering will not happen. This is what I have demonstrated in the previous session. Next one is, you need to be aware of something called the star schema, okay? What is star schema and what is snowflake schema? You need to be aware of this. You have something called dimensional data modeling. When it comes to data warehouse or any analytics project, you can hear this term called, dimensional data modeling. Okay, what is dimensional? There are two types of dimensional models are there. One is the star schema and the other one is the snowflake schema. So what exactly the star schema is all about? So what is star schema? Anybody has any idea? This is what the star schema. You can see that there is a sales table here. It's a transaction table. It contains, every hour or every minute, whatever the orders raised by the customer, the items purchased by the customer, that one will be there. Surrounded by this transaction table, you can see so many other tables linked with this table. So you can say that, the one side of sales factory, right, is, this is the one side of the sales factory table. The many side is star here, okay, sales. So one to many relationship, okay. Here you can see that similarly the date and, these two columns, these two tables will get, connected here, and product dimension table. And then let's, this is sales fact table, okay. So one side of this one is product and the many side of this one, the star, wherever you see star, that is many side. So here the product key and product key, are common. Hence, these two tables got created with the relationship as a one to many, okay. And so you might be wondering, okay, how the relationship got created. As soon as you load the data in your model, it will automatically, the Power Pivot deduct the relationship between the tables. Okay, detect the relation between the tables, but still, if you go ahead and review the relationship created automatically Power BI or Power Pivot, it is good. Okay, not all the time. Literally, you go by the relationship created by the Power BI Power Pivot. Sometimes you may have to create additional relationship. Okay, so in that case, you need to go and review the relationship automatically detected and created by Power BI. Is it clear? So your fact table, the sales fact table, is surrounded by multiple dimension tables. Hence, it looks like a star schema, right? Star. It looks like a stars. Hence, this is called star schema. Okay. See, the whole idea of all these this star schema is to keep all numeric values in a separate table called your sales fact table. I just write it here so that you should not get confused. All the numeric values will be stored along with the dimension key columns from your dimension tables. For example, here, this is product is a dimension table, customer is a dimension table, date is a dimension table, sales factor is a dimension table, reseller is also a dimension. This is also kind of a dimension table. All these dimension tables, key columns, here the product key and product key, the same product key you keep here. And since you are joining this one, right, the customer key, you have the customer key also here. So the fact table contains the dimension table keys plus the facts. Facts are nothing but the numeric values, the numbers. So what do you mean by number here? So in this case, right, the quantity and even the price and sales, gross sales, net sales, right? So these are in a margin, right? Margin. So these are your numeric values. So dimension keys plus facts are nothing but your sales fact table. So right here, so these are all the keys from the surrounded dimension tables. Along with that, you have the facts. Remember that they'll ask you in the interview, what do you mean by facts? Facts are nothing but measures. It is also called the measures. It is also called the measures or of the numeric values. Okay, numeric values or facts. Okay, so the same thing can be represented. They may use different terms. Okay, some say measures, nothing but the quantity, units sold, or the gross sales, net margin, right? These are your measures or numeric values. Okay, it's also called some numeric value, but usually we use the term facts or measures. Okay. So now the question is, right, why these dimension tables are required? Why we need these dimension tables? Because these dimension tables give context to your measures or the facts. For example, in this fact table, we have something called net sales is there, right? So net sales is there. Net sales is something like, if I say some number, net sales is 103K. Okay. The next question you will most likely to ask from is, so this is net sales fine. Is this an overall net sales, or is this for specific products or specific product group? Is this what the sales net sales that we achieved, or a specific quarter we achieved the net sales? What exactly this net sales 103K tells us? Right? So in that case, you are joining the surrounding dimension tables with this fact table to provide additional context to this one. Okay, for example, here, territory. Okay, so this is what territory is, kind of region. Okay, so region wise, specific region. So the let's specific north region, north territory, my net sales 103K. So now it makes more sense. Okay, so the dimension tables provides the context to the measures, and also each dimension tables contains the primary key. It is also called a surrogate key. They use the term called surrogate key. The data warehousing guys, they use this term very frequently. The customer key and the product key, these are called your surrogate keys or the primary keys. So if somebody is asking in the interview time, what is the dimension? Dimension table contains the primary key or the surrogate key along with the context, right? Along with the context or description to our measures in the fact table. The simple example is in the territory. So territory key is there, along with that territory name will be there here. One more column, like, territory name. So in that case, when you join these two tables, right? So for your north region, what is the total sales? So here, hence the sales territory dimension, it gives the description to your fact or measures. So north region, the total or the net sales is so and so. Okay. So dimension tables contains the surrogate key. Along with that, it will have the description for your facts. Okay. We can say that way also. The fact table is nothing but it contains the dimension keys plus the facts in it. Okay. Okay, to recap, in the case of star schema, we keep all numeric values in the fact tables. We keep all descriptive information and the surrogate key into other tables called dimension tables. See, the middle one is your fact table. The surrounding ones are your dimension table. The dimension tables contains the surrogate key, which is nothing but the primary key, along with the descriptive information. Right, descriptive information, that's all. Okay, and then fact tables are surrounded to the dimension that explain those facts. The dimension tables are not joined to each other. If you see, very clearly here, or if you take a closer look, all the dimension tables got linked with my fact tables. So this one got linked with this one got linked with this one got linked with. All the dimension tables got linked with fact, but we don't see the dimension table have the link here, right? We don't see any link between the dimension tables. That is the thing you need to remember it. Okay, this one, the star schema falls under dimensional data modeling. So now the question is, what exactly the dimensional data modeling is all about? So now the question is, what exactly? See, in the dimensional data modeling, as you said, right? So you have two types. One is the star schema design, and the other one is snowflake. Snowflake. I just try the snowflake schema. Don't get confused with the snowflake software. Okay, this is different. That is little different. The snowflake schema and star schema falls under dimensional data modeling. What exactly dimensional data modeling is all about? Okay, see, for example, you take the production system, source system, right? The source system, you have something like for a customer table, they have more than one table for the customer address. For the customer table, they have two different tables. For all the customer name, they store it here. You just think that, okay? And addresses are available here. Okay, address ID will be there. That address ID will be linked here. So for a simple customer table, they have broken down the table into two different tables, and they store all the customer name in the customer table and address in another table. This is in the source system. What do you mean by source system? This is your e-commerce site. Okay. Listen, this is your Zepto. Customers are ordering the products in the customer name, the address, and some other tables are there. Okay. This is the OLTP source, online transaction processing system source. And here you have these two tables are there. But when it comes to data warehouse, the one what we are in the star schema, what we do is we combine these two tables into a single table. Okay, so we hear the customer and address. So ultimately it will boil down to only one table. Instead of having two separate tables, related to customer, right? We join these two tables and put it in a single table. This is called denormalization. Denormalize. Dimensional data means nothing but denormalized data. I just write it here, denormalized. What do you mean by denormalized? we have to combine the tables, whatever the number of tables, right? Let's logically, okay, logically combine two or more tables into a single table. That is called a denormalized data model. So why do I need to denormalize this one? The reason is they have created two tables here in this case, okay, in the source system, because the source system should support concurrency. Multiple users across the globe, they are accessing your app and they're ordering. Or multiple people across India, they are ordering the product in your app or in your website. Hence, the performance should be pretty faster. That is called concurrency. Multiple people or simultaneously multiple people are accessing your app, mobile app, or your website. Okay, so in that case, to cater to this need, right? The concurrency, they design the table like this. Normalize the tables. They normalize the tables in the case of OLTP. Remember that in the case of OLTP, the tables are normalized. That means instead of storing everything in a single table, try to logically split the tables and store it so that the volume of the data is less, hence the performance will be pretty faster. Okay, there will not be much redundancy and the performance will be pretty faster. For that reason, they do normalization in the OLTP system. When it comes to analytics, opposite, denormalize it. Why? Anything you do join, any tables when you join it, right? The join operation is very expensive. It requires a lot of memory, CPU, all the things, especially when you work with huge volume of data. Okay, for that reason, what they did to overcome joining multiple tables, wherever it is possible, you denormalize the data and store it in a single table. Okay. So now the question is in the source system OLTP, for customer table, we have two different tables. We are storing the data. Address, we store it separately, customer separate. But here it is not going to cause any issue. But why do we have to think this is going to be a cause for the concern joining the tables? The reason is here we store the history. Take, for example, in the case of banking, 25 million customers are there, right? The number of customers are more here. So hence, if you store the customer data separately and their address separately, and if you join the two tables, it will literally slow down the performance. Something like, in your laptop, you have 4 GB RAM. If you play some PUBG game which requires 16 GB, what will happen? Venkatesh, what is going to happen? Your system will hang, right? So what they did, similarly, right, when you join the two tables, especially the huge volume of tables, it will literally slow down the performance. For that reason, what they did, they denormalized the data. They came up with something denormalized data model. So that is, the denormalized data model. In that, you have two types. One is the star schema, and the other one is snowflake schema. In the case of star schema, they keep the fact table in the middle, and then the surrounding, you can see they kept the dimension table. The dimension tables also, wherever possible, right? They will try to keep all the data in a single table. Okay, so this is what star schema is all about. Okay. Yes, Venkat, the system will hang, right? Yes. So for that reason, they do the denormalization to prevent the joining. So that's the reason why, right, nowadays the NoSQL databases are popular. They are strictly against joining the table. Don't join the table. Keep all the information in a single table itself. Now, they went one step further, vector databases. The FAISS, FAISS, Facebook's, the vector database, and Mulvis. Likewise, various vector databases. Even nowadays, the vector databases are very, very popular in the case of large language model like ChatGPT and so on. Okay. Just for your knowledge, I told you this one. Okay. At this moment, you remember what exactly star schema is all about. It falls under dimensional data modeling. What is, dimensional data modeling? It is also called it's a dimensional data model, nothing but denormalized data. So star schema is more popular. Even Microsoft recommends use star schema that is the best practice. That's what they suggest. Okay. And the next one is the snowflake schema. It is an extension of our star schema. Even in this case, if you see here, you have a fact table in the middle, right? The fact tables are surrounded by many dimension tables. But here, these dimension table itself, right? So this dimension table is not directly linked with the fact table. This dimension table is linked with this dimension table, and this dimension table is linked with fact table. So in this case, they are adding additional dimensions, right? It's kind of hierarchies. For example, under each dealer, how many locations are there? How many locations each dealers are? Or for example, each location, how many dealers are there? Or country, sorry, country is the super, thing, right? Parent, USA. Under USA, what are the location? For example, San Diego and San Jose. In San Diego, the location, sorry, yeah, dealers. How many dealer one, dealer two, etc. Right? This is kind of hierarchical data. So in that case, right, what Snowflake schema we do is we split a single table into more than one table logically. Okay, so you can store these three tables data in a single table itself. But what they say is when it comes to Snowflake schema, don't store all the the kind of normalization. Okay, denormalization is the idea of dimensional data modeling. When it comes to Snowflake schema, what they say is don't do denormalization, do normalization. Split the table logically into more than one, so that it will be like in a hierarchy, right? Location separately, country separately, dealer separately. So what is the advantages? So like I said, right, previously I told you joining multiple tables will be literally slow, especially if the table has huge volume of data. But as per Snowflake schema, what they say is it will have the advantage of, removing the redundant data, storing the, redundant data in the tables. If you remove the redundant data in the table itself, right, that will not slow down the performance. But the problem is still you need to join the tables, right? So for example, you want to see location wise revenue breakdown or the breakdown of revenue by location. In that case, the location table, it does not have direct link with the revenue table. Hence, it has to filter this table via this dealer dimension. It has to join with this table, and this table only can join with this one, right? So hence, even if you want to see the revenue breakdown by location, this table has to be joined with this table, and then only you can join with this revenue table. And hence, it requires multiple joins. This is the disadvantage or the flip side of using the Snowflake schema. But the positive side of this one is it requires a smaller disk space. So how how do you say it's reducing the the disk space? If you split it like this, what will happen? So here you store only the location ID here, right? Only location ID, not the region name or the location name. So for example, you have 10,000 dealers are there. So dealer ID and country ID, dealer name. Along with that, you have something like the location name instead of location ID, the region name, something like north, east region, south, east region, southwest region. Instead, you put NE and SC and SW. This one requires less space, and especially if the table has millions and millions of records, it saves a lot of space, right? It reduces the redundancy. Southeast, again southeast, southwest, south. Some customer order from southwest, one customer order from southeast. Hence, what happens? You're redundantly storing, these big names here. Instead, you store only the ID here. But still, right, Microsoft recommends you to use only star schema, which we discussed a while back. Snowflake schema in general, though it reduces the space. See, nowadays the hardware costs are cheaper, right? But the joining is still expensive. Okay. So due to multiple tables, query performance will. Then why do I need to learn about Snowflake schema? At least you should know what exactly Snowflake schema is all about. Okay. And the pros and cons now you understood. And star schema also you understood. Okay. What exactly and how it works, right? how we design it. That is what we discussed. Next one is the fact table. So the middle one is your fact table. The fact table contains measures. It's nothing but the items that needs to be aggregated. Okay. Total unit cost and total revenue, total profit, total units sold. Right. These are your measures. The aggregated values, which you or the measures, right, which you use it for aggregation, right? That is called your facts. The data in a fact table should be sliced and diced by the data of dimensions. So in the fact table, right, that needs to be sliced and diced by the data of dimension table. See, this surrounded by your dimension table. So if you want to slice the sales, right, based on the territory, North region, you want to see the, or APAC, Asia Pacific region, how much sales we made, right? So we are slicing in the sense, only the small portion of the specific part of the data you are slicing and dicing it with this one, okay? The data in a fact table should be sliced and diced by the data of dimensions. A fact table has a many-to-many relationship. Look here. So next to the fact table, you'll find star, star, star. So this is one side. One side, you can see one here, right? One, one. And this is the many side. And this is one, one, many side. Okay. So what do you mean by one to many side? Each region may appear multiple times in your sales fact table, because let's say you belong to Asia Pacific. So you have ordered with this specific company in this month 100 times. 100 times the same territory key will appear here. So hence here the same territory key will appear multiple times, whereas here the territory key will appear only one time, because in the dimension table the key columns are, or the key columns contains only the unique values, no duplicates. Okay. So measures are usually sliceable. Okay. Measures are like, net cost of goods sold by the Asia Pacific region or Europe region, by product, by customer, right? You can slice the measures with the dimension tables. Okay. So these are the types of fact tables. You have transactional fact table. As the name suggests, every day, whatever the transaction happen, it captures everything. Periodic snapshot is something like every once in a quarter, you take the data and then you store it in a other table. That is your periodic snapshot fact table. And then you have something called accumulating snapshot fact table. For example, each week you want to perform some aggregation, and then the aggregated values you want to store it in a other fact table. That is kind of an accumulating snapshot fact table. Next one is the factless fact table. It is also called as a bridge table. If you don't have the facts are nothing but numeric values in your fact table, it is going to be a bridge table. Okay, that is called your factless fact table. And here you can see that you have a table called salesperson and you have a table called region. Okay, if I ask you, give me the breakdown of the number of salesperson by each region. So in that case, the region table should filter this table. Okay, but you cannot create the relationship between these two tables directly. Why? Why? There is no common key column exists between these two tables. If you see key here, salesperson key is there. Can you see any other key column here? Nothing. But here also, you can see a key column, but this is sales territory key, this is salesperson key. These two are not same. Either the sales territory key should be there along with this key column, or this one should be available along with the sales territory key. It is not there. Hence, the region table cannot filter the salesperson table and vice versa. So that is where we have something called the bridge table, junction table, or bridge table. So what we do is here we keep both the tables key columns into this. Okay, and here you have one to many, and here also you have one to many. Okay, so here the sales person key in this table, it will have unique value. Similarly, in the region table, the sales territory column, key column will have unique values. But whereas here the salesperson key is not unique and the sales territory key is also not unique. Okay. So with the help of this bridge table, you can do the slicing and dicing between these two tables and between these two tables. Okay. So that is the idea of factless fact table. Any of I will show you one use case related to multi-dimensional tables. Oh, sorry, many-to-many tables, right? So how do we deal with many-to-many relationship? Okay, so that time you will be able to understand what exactly this one is all about. Okay, but if you see here, end of this is also a fact table, but here you don't have any numeric values, only the key columns from your other tables you have it here. Okay, so next one is yeah, relationship is nothing but filtering. Okay, and what is a cardinality? Cardinality is nothing but relationship between the tables. We have one-to-many relationship, one-to-many, many-to-one, many-to-many. These are the four different types of relationships are there. What do you mean by one-to-one? Give me an example. Give me an example. So Aadhaar number, right? So Aadhaar number. Let's say Aadhaar number is 101. This is associated with the citizen name. Okay, citizen name is, let's say, name is Tagore. The citizen name is Tagore. So the Aadhaar number 101 is associated with the Tagore. That means, right, each citizen can have only one Aadhaar number assigned. Each Aadhaar number is assigned with only one citizen. Each citizen is assigned with a single Aadhaar number. Okay, and also we can say this, right? Each Aadhaar number can be assigned with only one citizen. It cannot be assigned to more than one person, the same Aadhaar number. This is one example for one-to-one relationship. Okay, and what is one-to-many relationship? You have a listen. You have employee table, and then project table. You are working in multiple. So in your company, they are executing multiple projects. Okay. In this case, each employee, for each employee, employee name is, let's Preeti, and this is the employee name, and she is working on more than one project also. Let's say supply chain analytics project, she is working, and retail analytics project also she is working. 50% she is contributing here, remaining 50% she is contributing here. A single person, Preeti, is working in more than one project. So, right, so one, this is many, right? Many side. So this is one side, this is many side. So this one, this is many side. Star represents many side. Single employee working on more than one project. So what is many to one? Many to one is something like the same example, okay, employee and project. And here, like I mentioned, Preeti and Ashok and let's some person, okay, Lavanya, right? Lavanya. So in this case, a single project, supply chain analytics, multiple employees are working, or multiple employees are working in a single project. This is M, this is one, many to one. This is example. Understood? Single employees working on multiple projects, that is your one to many. Many to one is opposite. Multiple employees are working in a single project. Okay, one to many to one, and many to many relationship. So next one is the many to many relationship. Give me an example for many to many relationship. The same thing, right? So what is many to many relationship? Employee and project, take the same thing here. We combine these two things, right? One to many to one. So multiple employees, for example, employee one, employee two, employee three, is working in a single project, supply chain analytics. And each employee is Each employee is, working in more than one project. Retail analytics, right? Maybe 60% of the time he spends here, remaining 40% of the time he spends here, right? So this is your many to many, right? Sorry, here a single employee is working on more than one project. Each project contains multiple employees, hence it is called many to many relationship. But in the case of many to many relationship, employee table and project table, if you see the key column, it's completely independent. Okay. So you don't see any key related to project key in your employee table, or in the project table, you will not find the employee key here. Okay. So in that case, you need to have a bridge table. Okay, you need to have a bridge table. Okay, so that's how we implement many-to-many relationship. But in the case of Power BI, Power Pivot, without having the build bridge table itself, we can do we can do the filtering many-to-many between the many-to-many relationship tables. So I just repeat it one more time. So whenever you encounter a many-to-many relationship, you have to create a bridge table. Okay, that is the universal rule. You take any analytics project. Okay, so guys, remember that. So the relationships, whatever I explained you, it is not specific to Power BI. This is a universal concept. You work in any project, data modeling will be there. So in that case, these concepts are applicable there also. Okay, but here when it comes to many in general, right, what we do is both, let's say you have many side of two tables. So what you do is to filter these two tables, right? You need to use a bridge table. But when it comes to Power BI, in the case of Power Pivot, without even creating the many relationship between the tables, many relation will be there. Without creating the bridge table, you can filter the many sides of both the tables. Okay. So one-to-many relation. This is your one-to-many relationship. As I explained a while back, each employee is working on multiple project. Single employee working in other example is single car manufacturer produces many cars, right? A customer can order more than one item. These are the example for one-to-many, and many-to-one is more than one employee can work in a project. More items ordered in a single order. And how to create relationship or data model design in Power Pivot. That is the one we will take a look at it now. I just jump into the Power BI desktop. Many to many relationship. Yeah, I'll just open this one. So why many to many? Will start with the simple one. I will see to that. I know if I can create, if I can demonstrate everything in a single report file itself. Let's wait for a few seconds. Let's wait for a few seconds. Yeah, wait for a few more seconds. I sorry, I should have opened it earlier. It's not open here. Sometimes going to close it and one second. Just data modeling part one. One second, I just click on it one more time. Okay, at last it opened. Thanks for all your patience. Wait for a few more seconds. Once again, I just opened the other file. It's literally hanging my system. I fixed that issue, but still it is hanging. Okay, part one. Yeah, part one got loaded. Look here, I have already loaded, these files. Maybe, right, these are all Excel files. I loaded the DIM category Excel file and customer dimension table, location dimension Excel file, all the Excel files I loaded. You know very well, once we load the Excel file or anything, right, it will be considered as the tables. These are dimension tables. Okay, I'm just for the time being, I just close that one. Yeah, data modeling part one. So, these are the dimension tables. Along with that, we have something else called date dimension tables. Okay, I go to the table view quickly, and then I just show you some sample data. Look here. If I click on the DIM category, which is nothing but category dimension table, we can see the category ID and category name. Wait for some time. It will take a few seconds to populate the data here. Again, depends on the volume. Okay, here the volume of data is very less, but still it takes few seconds to load the data here. Wait for some time. Similarly, when you click on the customer dimension table, you can see the data related to customer dimension on the left side here. Okay, it will take some time to display the data here. I just click on the customer dimension table and category. Also, it takes time. Look here, category dimension table. I clicked on it. You can see the category and category name. And customer dimension also, we can see the customer ID and then first name, last name, gender. Okay, these are the the columns that you can see there. And date dimension, you can see the date, year, quarter, and the location dimension. Now we will switch to the model view. I just click on the model view. The moment you load all these files, data, which are nothing but the tables, right? The relationship gets created automatically. Look here, the lines, the links. I'm talking about these links. This is the wire, right? So product dimension and the category dimension table, location dimension table, date dimension table. I just, I just maximize the size here, or I'll create some space here. Okay. For example, this is my sales fact table that is surrounded by my dimension table. Like here, I have the customer dimension table and then product dimension table and category dimension table and location dimension table. And forget about this. And you can see the date dimension table, right? The date dimension table and this one was not linked together. Okay, and but here we have the sales W04 and these two tables got linked with the date dimension table. So you can also, use this date dimension table. So in this case, right? Okay, before we get in there, first of all, let us understand how the relationship got detected automatically, how it created the link between these tables by default by Power BI. Okay, so what happens is, look here, if I hover the cursor, which means if I keep the cursor on top of this line, you can see on both the side of the tables, right? Which column got highlighted? Cust ID, cust ID. Here the cust ID, here the cust ID gets highlighted. So which means since I have a common column cust ID available in these two tables, it created the relationship between these two tables, okay, using the cust ID column. But here this is one side and here you can see star. Star is many side. So each customer, for example, Venkatesh, so he ordered more than one time, right? So he goes to the shop, on a daily basis, purchase grocery items. So is this single person Venkatesh appears multiple time in this table. But in this table, Venkatesh, let's say Venkatesh customer ID is C008. It should be unique. Okay, the C008 should not repeat more than once time. But whereas here the C008 can appear more than one time. C008 is nothing but Venkatesh. Okay. So this is your product dimension table. Each product can appear more than one time in the fact table. And here, there is a category dimension table, but this table got linked with the product dimension table, because if I keep the cursor on top of this one, we can see that cat ID and cat ID. Okay, in this case, what happened? The category dimension table got linked with product dimension table, and then the product table dimension table got linked with this table, because here, if you see here, if you hover the cursor here, both the table product ID column is there, but cat ID is not available here. But these two tables have cat ID, hence it creates. So this is Snowflake schema, okay? And you have the location dimension table here. Okay, this location table dimension table have location key column here. This column is available here also. Hence, you have one-to-many relationship. But if you see here, this fact table is surrounded by dimension tables. Just because the dimension tables are surrounded by this fact table, we cannot say it's a it's a star schema, because there are some dimension table, right? It got normalized, which means the splitted, right? So ideally, category and product, you can put it in a single table. Anyhow, we will see that in the next session, okay? What is denormalization, how to do the denormalization. We'll take this as an example, and then we'll look at it, okay? So here, in this case, this is what has happened. It's a Snowflake schema, because the dimension tables, all the dimension tables were not directly linked with your fact table. In the case of Snowflake schema, all the dimensions tables will not directly link to their fact table in the case of Snowflake schema. That is what is happening. But end of the day, you can see that the customer ID from the customer dimension table got, that one will get, that one got linked down with this one. The product ID from this table moved down to your fact table, and then the location key is moving down from your dimension table to your fact table. But here the category ID is linked with the category of your product dimension table. This one was not detected automatically. The reason was, here the column name should be same. For example, here you have custody, and here also the custody. Both of them are same, right? The names are same. For example, you have custody, here customer ID is there. How Power BI will know the custody and customer ID columns are same, or the common column, right? So in that case, you need to explicitly create the relationship between. How do I create the relationship explicitly? I'll show you that. For the time being, I just click on this link and I am going to delete it. You can also create the relationship manually. I deleted this one. Still, it takes time. It is a little bit slow. Let's wait for a few seconds. This line will go away. That line went off, right? The link or the relationship between these tables got removed. And if I wanted to create the relationship, manually, how do I do that? Two approaches. One is keep the cursor on top of the key column, and you just drag this custody column and drop it on top of, exactly on top of your sales fact tables custody. Don't drop it on any other column. You have to drop the custody column from your customer dimension table to sales fact tables customer ID column. And then I just drop it, wait for some time. It'll look here, your line got created. So this is one, this is many. And to make sure that you have dropped the custody column from your customer dimension table to your sales fact table custody column, right, you just keep the cursor on top of this. This is called hovering the cursor. Okay, hover the cursor on top of this. You can see, yes, these two tables got highlighted with custody. We have created the relationship between these two based on the common column custody. Very good. This is one way of doing it. Okay. So other approaches, you delete this one. So here on top, you can see something like manage relationship. Can you all see it here? Manage relationship. Okay. And you can double click on this. This is another way of creating the relationship. Okay. You can just double click on it. Wait for some time. It's still working on it. I just double click on the manage relationship and wait for a few seconds. And here, right, so in the manage relationship, look here, the customer dimension table is not there, right? So what I do is I'm going to click on new here. So I'm going to select the customer dimension table first, and then the next, I just select this one. We need to link with which table? Customer dimension sales fact, right? You need to select the sales fact table. Now we can see that customer dimension table and sales fact tables, the sample data, not the entire data. Okay. Here you can see the customer custody column got highlighted with the gray color. Even here also the custody column got highlighted with gray color. So it automatically detected the common key column exists between the two tables and then it highlight. Sometimes, right, you may have to click on it. So sorry, no, it is not automatically. So you need to click on this common column, and here also I clicked on it, right? Custody got now highlighted. Okay. So you need to tell explicitly which columns between the two tables are common. Custody. Can you see first name here? No, right? Can you see last name? No, right? Gender, you don't see here. Similarly, location key and other columns you cannot see here. And product ID also, it is not there. Only the custody is there. Here also custody. That means these two columns are common between these two tables. Hence, we can create the relationship. But when you see coordinate section here, one-to-many relationship, each customer can appear more than one time in your sales fact table. And the cross filter direction is important. So here, when I click on the drop down, you can see single and both. This is an interview question. One of the interview, they asked this question: can you tell me the properties of cross filter direction? She was literally bluffing. Okay, sorry, baffling. Okay, here she got confused first of all, and again she repeated. So can you tell me the two properties of cross filtration? One is single, and another one is both. The default one is single. So here we have selected the two common key column between the two tables. I'm going to hit OK now, and I'm going to close this one. Soon you will find a link. Look here, a link got created between these tables. Then you can close this one, and if you keep the cursor on top, you can see custody in both the tables got highlighted. This is how you can create the relationship manually. Either you can drag and drop the common key column, manually, or you can click on the manual relationship. There you can click on the new, and you can select the tables. You can specify the common key column between the two tables, and hit OK. Then the relationship will get. This another approach. The other common approach is, as soon as you load the data, Power BI automatically detect the relationship between the table. Then why do I need to create the relationship manually? Two reasons. One is, here the key column is custody, but here also the key column is there, but the key column name is customer key. Here customer key is there instead of custody. Customer key is there. As domain expert, we know very well the cust key column and custody contains same value. So in that case, right, you need to manually create the relation between these tables. But Power BI or the Power Pivot will not detect the relationship in this case because the column names are different. Though the data are same, right? But the column names are different. Hence, it will not detect the relationship. In that kind of situation, you have to create the relationship explicitly by either by dragging and dropping it, or you can click on the manager, you can create it here. That's all, guys. Okay. So here, you can see that we have implemented customer dimension, product dimension, category dimension location table, and then the sales fact table also. What I will do is we have date dimension also. And the date dimension, right? So this one got created with some other dates. Anyhow, for the time being, let's ignore that. I just quickly go to the report canvas. I just click on the plus and I'm going to click on some table visual. I just resize it. For example, you want to see the category, category wise total sales performance. You need to click on the sales fact table. Here only you have the sales amount, drag and drop this. Now it is doing the filtering, but when it comes to category dimension, it cannot do the filtering directly with the sales fact table. It has to do the filtering via your product dimension table only. Hence, it is better we can combine these two tables in a single table. That we'll see it in the next session. Okay, so now you understood, right? So now in beverages category, how much total sales we made. In dairy category, how much total sales. We can see that it is doing it does the filtering correctly, perfectly. There are no issues here. I just increase the font size. Yes, I will increase it. Don't worry. So it is doing perfectly. So now you understood what is data modeling, how to implement them. So your fact table, was surrounded by majority of the dimension tables, but this dimension table is not linked directly with sales fact table. Hence, it is called your snowflake schema. We will convert this to star schema in the next session. Okay, and next one is look here. This is a one to many, one to many, one to many, one to many. Okay. So then other scenario where you need to create the relationship explicitly is sometimes you may have to create more than one relationship between the tables. When, for example, I have a date dimension table. Look here, I just click on the dim date and I just go to the table view. And then here, okay, I explicitly select the dim date. And here, right, instead of using this one, see, there is a function called calendar function. In the calendar function, the minimum and maximum dates you need to specify. Okay. Sales, not the sales W04. I'm going to use sales fact table. Order date is there. And here I'm going to remove this one also. I'm going to press enter. So your date dimension table contain the minimum order date, maximum, but here the start date in calendar one cannot later than the end date. That in convention cannot be later than the end date. Okay. Oh, there is something wrong with the data here. Okay. Okay, first let me check the. Okay, I just undo this. Okay, I leave it as it is. I just go and check the sales fact table. There is something wrong here. The order date 11/20 to 11 to 2021. 10/22. Oh, it's a text date, right? Text data. That's the problem. We may have to convert the date data type. What I'll do is obviously I go to the transform data. That's what the date column and all, right. You need to take a close look at it, whether the date column got assigned with the date data type or something. Otherwise, it will cause these kind of confusions. The default one is string. Sales fact table. And here, Okay, there is some issue here already. Okay, data source error. Okay, what is the problem here? Edit settings. Hmm. Salespack.xls. I just load it again here. Let me see. Sales fact one. Hmm. Or else I just cancel it. Nothing wrong here. I'm not sure why it's not picking up the sales fact file. Okay, here the I just discard the changes. Okay, what I do is I just click on the order date here, the list price and order date, and the data view, right? Table tools. Let me see if I can change the date here. But this is a problem. If I change it, it is gone. Okay, any error comes, we are gone. I just go back to the some data, refresh review. Could not find, oh, XLS. I think the XLS file got XLS X. I'll just make it XLS X. I think the file got corrupted. I don't know. Yes, now it got loaded and we can see that the change type, everything put together. So all the other steps carried out automatically by this one. Maybe the sales fact table is not available. Look here, the order date is a ABC, right? That means the text data type. Click on this one, and then you can change to date here itself and see if this is going to cause any issues. Yeah, now it got converted date data type. Fine. And now I just go and close and apply. Yes, the sales fact table got loaded. And what I will do is I'll just go to the dim date dimension table quickly. Here I just go back to the table data again. I just select the dim date dimension. Here I just change the table name here. Okay, the now we fix the issue. What was the issue? The date column was not in the date data type, and here the sales fact table order date. That's all. Okay, the minimum, the least order date and recent order date, I passed as an argument to my calendar function. The calendar function, what it does is it returns a table with a date column. From the date column, I extracted year, explicitly. There is a year function. The dim date of date column, I passed as an argument to year. And similarly, in the quarter column, there is a function called quarter that is already available. Okay, quarter. Inside the parenthesis, I mentioned this date column, but this date column belongs to which table? Dim date. Okay, dim date is a table name. In that table, this date column is there. You need to specify the table name along with the column name. Okay, that's how this one got created. I just go back here. So I just go back to the model view. This time, what I will do is I will drag this date column with the order date. So now it will create the relationship between the date dimension and sales fact table. So if I hover the cursor on top of this line, you can say that the date dimension tables, date column, and order date got linked. So the reason why I was, I was talking about dim date table, right? Sometimes you may have to create more than one relationship. See here, the date column linked with this table's order date column, and here we don't have the ship date column. Supposing, let's say you have another, oh, for that reason I link the table. Okay. Sometimes, right, let's say you have a ship date column here. So again, you can drag and drop the date column with the ship date column here. Okay. So you have two relationship get created. Okay. I think since we don't have this, the ship date column, right? I have created it manually. Okay. What I will do is I just go here, and here I applied the filter. I just in the Excel file. Okay, I just select all. I'm going to click on this one, and we have the order date. Yeah, order date is there. I just copy paste it, and then I just put it here, paste special. I just say this is my ship date. Okay, I just rename it as ship date. Because in this table I don't have the ship date column. So in this data set, okay, I will create it explicitly. What I will do is here I just subtract the 2 days. Okay, from order date -2. If I give, what will happen? Will, yeah, so 2 days, if I subtract it, it is correct. 21 Feb, right? So 21, if I subtract, okay, 2 means 1031. Is this correct, guys? Okay, let us see. I just drag and drop this till the end. Yeah, yeah, I just drop this here and see what happens. And then I just save it here. And if I go back to my Power BI desktop, and if I refresh this, that new column ship date should also be made available now, right? It has to reload everything again. In the column 12 of table was not found. Table was not found. Okay. So, okay. Here there is an issue, right? Because the table, I selected additional columns, there were blank columns, or that's why it shows something. The column 12, 13 and all is there, right? So you just think, right? You can link a date column with more than one. So not only the date column, right? Some cases, right? You may create more than one relationship between the two tables. So say two tables, okay? Not necessarily only one relation. Sometimes you have to create more than two relationships, three or four relationship also, okay? So, okay. What I will do is I will create another date dimension table. I just go here. Look here. I will create. I just copy this one. Okay, to show you how the relationship will look like if I create more than one relationship between in the two tables. Okay. I'm going to click on the table tools, and here I'm going to click on the new table. See, currently I'm the table view, clicked on the table tools, and I clicked on the new table because I'm going to create another date dimension table that is for between the sales W04 table and then date dimension table. Okay. Let's this is my dim date one. Okay. And here I'm going to use, instead of sales order fact, I'm going to use, because some data issue, right? Sales underscore W04 in this order date, and I'm going to use the same thing here, maximum. Okay, here I just use that one. I'm going to press enter, and I'm going to remove that one, press enter. Now the calendar function will return a table with the date column. Look here, right? So with the date and time format, I just click on the date column here. So here date time is there. I don't need the time. I just select only the date here. This is how you can create the date dimension table. Okay, and then what I do is in the column tools, I can see a new column. I just click on it. And I'm going to create a new column. So look here, I create a new column. So now what happens? What is this? For the new column, it is not showing anything. Yeah, in this new column, I just say year is equal to, there is a built-in function called year. Look here. Inside this year, I just specify this date column. This date column belong to which table? Dim date one date column. Similarly, you can use quarter, day and all to create another column. So look here. So this is enough now for to demonstrate that one. Okay, dim date one. Now you will find the dim date one here also, because just now I can look here dim date one. So here what I do is I just create the relationship between the here you can see that the order date and ship date columns are there. Okay. So here I just drag and drop the date column with the order date column. And if I scroll down here, I'll find now the relationship got created between date and order date. And then again, we have something called ship date. This date and ship date column will get linked. Date and ship date column. So with this, you understood between the tables, you create more than one relationship. But when you create more than one relationship between the tables, the first time, whatever the relationship that you created, the date and order date, right? That is the one is the active, and the other relationship between the date and ship date is called inactive relationship. You can see the inactive relationship got, you can see that line is dotted line, right? This dotted line is your inactive relationship. This is your active relationship. Yes, I write it here. So this one is your active relationship. You can create only one active relationship between the tables as of today. Okay. Maybe in future release, they may remove this restriction. Okay. But as of now, as of today, between the tables, you can create only one active relationship. And after you create the first relationship, rest of the relationships are called your inactive relationship. You can identify the inactive relationship with these dotted lines. So active and inactive relation also we discussed. Yes, I don't want to overload you with so many things. I know yesterday's session was cancelled because of my laptop problem. And right, so what we'll do is we'll continue next weekend to discuss about what is active and inactive relationships all about. And also we will see what is the role-playing dimension. Role-playing dimension is not specific to Power BI. It is a universal concept. Any data, dimensional data model, you can see the role-playing dimension also. Okay. That we'll discuss it in the upcoming weekend. Any questions? Yes, I'm going to wrap up this one. Yeah, I'll share this file, right? Kavya and Rupa. Okay, I'll share this file. Don't worry. Okay. Fine. Since you don't have any questions, I'm going to wrap up the session. Next